NCM Learning Center.
Good morning friends. In this video, we are going to solve these diode problems. This question is from GATE 2024 Electrical. Okay, we will solve these questions. Objective of the question is, we have to find the current flow through the diode D1 in milliamperes. Already we discussed the diode concepts. That concepts link is attached in the discussion of the video. If you want, just refer that video. Okay. First, we have to check whether the diode D1 and D2 is on condition or off condition. If the diode is on condition, it will act as a short circuit because it is the ideal diode. If the diode is off condition, it will act as a open. How to check whether the diode is on condition or off condition? We know that for ideal diode, if open circuit voltage against the diode is greater than 0 volt, it will goes to on condition. Otherwise, it will goes to off condition. Okay. This is for ideal case. For silicon diode, if open circuit voltage against the diode is greater than 0.7 volt, then only it will goes to on state. Otherwise, off state. Okay. Here given is ideal diode. So, first we have to find the open circuit voltage across the diode. Then only we can say whether the diode is in on condition or off condition. Okay. So, it is assumed that both the diode D1 and D2 are open. Let's take the anode voltage of the diode D1 is VA1 and cathode voltage of diode D1 is VK1. Similarly, for the diode T2, anode voltage is VA2, cathode voltage is VK2. Here diode D1 and D2 assumed are open conditions. So what is the value of VA1? VA1 is 3 volt. VK1 is equal to 0 because it is open. So it is connected with ground. VK2 also 0 volt. Next we have to find VA2. Remember that the diode D1 and D2 are open condition. So we can easily find VA2. Use potential divider. Voltage divider. Here two resistors are connected in series. We have to find the voltage across 1 kilo resistors. Here this is two resistors are equal. See the voltage division will be equally divided. So 10 volt will be divided into 2. So VA is equal to 5 volt. Now the voltage across the diode D1 VA1 is equal to VA1 minus VK1. Anode voltage minus cathode voltage. The anode voltage is 3 volt, cathode voltage is 0. So we will get the anode to cathode voltage. Open circuit voltage against the diode D1 is 3 volt. Next for diode T2, voltage against the diode T2, VK2 is equal to anode voltage minus cathode voltage. Here anode voltage is 5 volt, cathode voltage is 0. We will get 5 volt. Here VK2 greater than VK1. That means open circuit voltage across the diode D2 is greater than open circuit across the diode D1. So diode D2 will come to first on. Now we have to check whether the diode D1 is on or off after diode D2 will goes to on condition. Okay. So diode D2 is on. We have to assume diode D1 is open because we have to find the open circuit voltage across the diode D1 after diode D2 on. So replace the diode D2 by short and D1 is open. Okay. Let us consider this voltage is V1, node voltage is V1 and this voltage is V2. Anode voltage of diode D1 is 3 volt. Cathode voltage of diode D1 is V2. So we have to find V2 voltage. Now objective is we have to find the open circuit voltage across the diode D1. Anode voltage is 3 volt, cathode voltage is V2. So we have to find V2 first. So apply current law at node 1, V1. Assume all the current outflow from the node. So we will get V1 minus 10 by 1 kilo ohm, V1 minus 0 by 1 kilo ohm plus V1 minus V2 by 1 kilo ohm. Okay. This is ideal diode. So D2 across short circuits. Simplify this equation. you will get 3V1 minus V2 is equal to 10. Let us take this equation as 1. Next, find Kirchhoff's current law for the node 2. So assume all the current from outflow node. Here the diode D1 is open condition. So the current flow through the diode D1 is 0. V2 minus V1 by 1 kilo ohm plus V2 minus 0 by 1 kilo ohm is equal to 0. Simplify this equation, you will get 2V2 is equal to V1. Our objective is to find V2 value. So substitute this V1 values in this equation 1, we will get V2. V2 value is equal to 2 volt. Here cathode voltage of diode D1 is 2 volt. Anode voltage is 3 volt. Cathode voltage is 2 volt. So open circuit across the diode D1 is 1 volt. Anode voltage minus cathode voltage 1 volt. It is greater than 0 volt. So definitely diode D1 goes to on condition. Now always the diode D1 and D2 will act as short circuits because on condition. So replace the circuits. Diode D1 and D2 will short. Now objective is to find the current flow to the D1. It is very easiest. Now the circuit becomes basic electric circuits. So let us take node voltage V1 and V2. Now find V1 and V2 values. So apply Kirchhoff's current law on node 1. Assume all the current flow outflow from the node. So here V1 minus 10 by 1 kilo ohm plus V1 minus 0 by 1 plus V1 minus V2 by 1 is equal to 0. Sum of outgoing current is equal to incoming current. Here incoming current is equal to 0. Simplify this equation, you will get this. Let us take this equation number as 2. Here V2 voltage is directly given 3 volt because the 3 volt is directly connected at the node V2. So V2 is equal to 3 volt. Substitute this values in this equation number 2. We will get V1 is equal to 13 by 3. Now V1 and V2 is known. Now our objective is to find the current flow to the diode D1. How to find? Just apply Kirchhoff's current law at this junction V2. The incoming current is I. We have to assume this current outgoing currents. So I is equal to this outgoing current V2 minus V1 by 1. This outgoing current V2 minus 0 by 1 kilo ohm. Simplify this equation, you will get this equation. Here we know that V1 and V2. V1 value is 30 by 3, V2 value 3 volt. Substitute here, we will get current I. So I is equal to 5 by 3, I is equal to 1.66 milliampere. This is the answers. Okay. Continuously watch our channel. Definitely you can get the good knowledge. Good. Thank you.
Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.